Hello friends, this video on polynomials part 6 is brought to you by examfear.com. No more fear from exam. Now let's see degree of a zero polynomial. I told that degree of a zero polynomial is undefined. Why? See, zero polynomial is 0, right? So 0 I can write as x to the power 0, or I can write as 0 x to the power 1, or I can write as 0 x to the power 2, or I can write as 0 into x to the power 3, or I can write as 0 into x to the power 4, or I can write as 0 into x to the power 5. All these actually will give you 0, which is a zero polynomial. So zero polynomial actually you don't know whether you are multiplying with x to the power 0, x to the power 1, x to the power 2, x to the power 3, x to the power 4, x to the power 5. Right? So if you are multiplying with x to the power 0, the degree is 0. If you are multiplying with x to the power 1, the degree is 1. If you are multiplying with x to the power 2, degree is 2, and so on. So the degree is not defined. It can be 0, it can be 1, it can be 2, it can be 3, it can be 4, it can be 5. The same is not true for constant polynomial. For example, let's say constant polynomial 5. 5 will always be 5 into x to the power 0. I cannot say 5 into x to the power 1. That is not true because this is equal to 5. This will be equal to 5x. Correct? So in case of constant polynomial, the degree is 0. But in case of zero polynomial, you don't know. Right? Because you can multiply with any of these variables with different powers. So we say that for a zero polynomial the degree is undefined. Please note, important concept, for zero polynomial degree is undefined, and the reason is because 0 can be multiplied with any variable with any power, and thus it can have any degree. Since it can have any degree, the degree is not defined. Now we'll see polynomial with more than one variable. Till now we have seen most of the polynomial in this fashion, where the variable is only one. Here we say px, right? So now we'll see polynomial with more than one variable. So we'll write as pxy. For example, I say that x square plus y square plus 2y plus 3. So if you see, it has variable x and y. Okay, or I can say x square plus y square plus, let's suppose, z square plus 3. So it has three variables x, y, z. So here I'll say p of x, y, and z. Okay, so we'll not study in detail, but the point the reason I had the slide in my video was I wanted to show you that yes, we can have polynomial with 2 variables, 3 variables, 4 variables. But in this class, we'll be focusing only on polynomial with one variable. Let's take some numerical. So which of the following expressions are polynomial in one variable and which are not? So we have to first check whether they are polynomial, and then we have to check if they are polynomial in one variable. Let's take this. So polynomial, as I told, it will have variable, constant, and exponent will be whole number. So let's take this x to the power 2, x to the power 1, and x to the power 0. All these 0, 1, 2 are whole number. So it is a polynomial. Is it a polynomial in one variable? If you see, there is only one variable x. So it is polynomial in one variable. So it is correct. Let's take this. Y square plus root 2. So y square, this I can write as y into 0. This is a constant number. So if you see, the power are 0 and 2. So it is polynomial. It is in one variable. Yes, the only variable is y. So it is one variable. Let's take this. T to the power 1 by 2. 3 into t to the power 1 by 2, and then t into root 2. And here is t to the power 1. So this is okay. The power is whole number. This is not okay. Since the power is not whole number, this is not even polynomial. Since it is not even polynomial, so there is no point in checking whether it is one variable or two variable. Similarly here, y plus 2 into y to the power minus 1. So this is y to the power 1, this is y to the power minus 1. 1 is a whole number, minus 1 is not a whole number. So it is not even polynomial. Since it is not even polynomial, there is no point in checking whether it is one variable, two variable. Here we see x to the power 10, y to the power 3 to the power 50. All three are whole numbers, so it is a polynomial. But how many variables? 1, 2, and 3. So they are 3 variables. So it is not polynomial in one variable. It is polynomial with 3 variables. So if you see, only these two are polynomials with 1 variable. The last one is polynomial with 3 variables, and these two are not even polynomial. I'll request you guys to pause this video and understand why these are polynomials and why these are not polynomials, why these are polynomials in 1 variable and why some of these are polynomials in 3 variables. Now we'll write the coefficient of x square in each of the following. So coefficient of x square, if you see in first, this is the x square term and this is multiplied with 1. So the coefficient will be 1. This is also x square and this is multiplied with minus 1. So the coefficient will be minus 1 for x square. This is x square term and this is multiplied with pi by 2. So the coefficient will be pi by 2. There is no x square term, so I can assume it is 0 into x square. So I can say that the coefficient of x square is 0. Please pay attention here. Since there was no x square term, so I assume that there is a x square term which is multiplied by 0. So the coefficient of x square is 0. Here there was a negative sign, so the negative sign came. Here we have multiplied with pi by 2, so this coefficient is pi by 2. And here there was no sign, it's only multiplied with 1. For example, if you take 2 plus 5x square plus x, so here the coefficient of x square will be 5. 2 minus 3x square plus x. Here the coefficient will be minus 3 for x square. Okay. Give one example each of a binomial of degree 35 and a monomial of degree 100. Binomial of degree 35, that means highest power is 35. Binomial means 2 terms, so I can have another term as, let's suppose, 5. This is a binomial of degree 35. Next is monomial of degree 100. So maximum power is 100. It's a monomial, it will have only one term. So this is the example of monomial of degree 100. For binomial of degree 35, I can have many answers. I can also say x to the power 35 plus x to the power 34, or I can say x to the power 35 plus x. I can have so many answers for this. Okay, please note these are all binomials, 2 terms, and degree 35 because the maximum power is 35. This is a monomial, only 1 term, degree 100 because the maximum power is 100. Write the degree of each of the following polynomials. Degree is nothing but the highest power. First, let's check if it is polynomial. If yes, we'll check the degree. So x to the power 3, 2 and 1. It is polynomial. Yes. Let's take the degree. Degree is the highest power. X to the power 1, 2 and 3. The highest power is 3. So the degree is 3. Let's check this. Polynomial, yes or no? This is constant and this is y to the power 2. This is whole number. So it is polynomial. Maximum power is to the power 2. So the degree is 2. Let's check the 5t, t to the power 1. And this is root 7 to the power 0. So 0 and 1. Powers of 0 and 1 both are whole number, so it is a polynomial. Let's check degree. This is t to the power 1, t to the power 0. The maximum power is t to the power 1, so the degree is 1. Let's check this. 3 is nothing but 3 into x to the power 0. Maximum power is what? Maximum power is 0. So degree is 0, and this is also polynomial. So in this case the degree was 2, 3, it was 2, 1 and 0. Right? For degree for the first polynomial is 2, degree for the second polynomial is 2, degree for the first polynomial is 3, degree for second polynomial is 2, degree for third polynomial is 1 and degree for fourth one is 0. You have to classify the following as linear, quadratic and cubic polynomials. Linear is what? Where degree is 1. Quadratic is what? Where degree is 2. Cubic is where degree is 3. So this is a polynomial, yes, because all the exponents powers are whole number. And the maximum power is 2. Since the maximum power is 2, it has to be quadratic. Let's check this. X to the power 1, x to the power 3. Both are whole number, so it is polynomial. Maximum power is 3. 3 is what? Cubic. So it has to be cubic. Let's check this. Y to the power 1, y to the power 2 and this is y to the power 0. All are whole numbers, so it is polynomial, yes. Maximum power is y to the power 2. 2 is what? Quadratic. So it is quadratic. Let's take this 1 plus x. 1 is a constant, x to the power 1 is a polynomial, maximum power is 1, 1 is linear, so it is linear. 3t, t to the power 1, maximum power is 1, so it is also linear. R square, maximum power is 2, 2 is what? Quadratic, so this is also quadratic. X to the power 3, maximum power is 3, so it is cubic. Pretty easy. And if we talk about monomials, binomial, trinomial, this is 2 terms, so it is binomial. There's 2 terms, this is also binomial. 3 terms, this is trinomial. 2 terms, again binomial. 1 term, monomial. This is also monomial. And this is also monomial. You see, both are independent. The powers and the number of terms are totally independent. Okay, so you can have quadratic which is monomial, you can have quadratic which is binomial, you can have quadratic which is trinomial. Find the value of each of the following polynomials as indicated values of the variables. So we have to find the values of these polynomials at x is equal to 1, for this at y is equal to 2, and for this at t is equal to 1. So first we have to find, first I am trying to solve p of 1, right? That will be nothing but 5 into, replace x with 1 minus 3, x with 1 plus 7. So if you solve this, this becomes 5 minus 3 plus 7. 5 minus 3 plus 7 is 9. Similarly, try to do for the second one. Q of 2 will be 3, y cube will become 2 cube, minus 4y will become 4 into 2 plus root 11. So we solve this, this becomes what? 2 into 2 into 2, 8, 8 into 3 is 24, minus 2 into 4 is 8 plus root 11, and that is nothing but 16 plus root 11. So that is the value of these polynomial at y is equal to 2. Let's talk about this third polynomial at t is equal to a. So I have to find p of a. Replace t with a. So t4 becomes a4 plus t5, t3 becomes 5a3. T square becomes a square and plus 6. So this will be the value. Nothing great. You have to just substitute the value of x as 1 in the first polynomial, y as 2 in the second polynomial, and t as a in the third polynomial. I believe you must have done these kind of questions in your past classes. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.